Okay, this is the second video of the Galaxian debug. If you remember the last video, we started looking at this bootleg Galaxian, and we ran a memory map on it. It came up with something fairly sensible. We then went and checked the video RAM that it detected at address 5000, and it passed that, no trouble at all. It checked some work RAM area that was fine. It did show up one block of RAM that was write only or potentially bad, which was interesting. But the other thing that it showed up was that when we tried to read the ROM space, we were getting garbled data. Everything started with an F, something or other, F012, whatever. And when we ran the stuck check on it, it showed up 4 bits of the data bus D4 to D7 as stuck, which indicated that those data bits were not changing state, whereas the other ones were. From that point, what I've done is I've basically unplugged the daughter board, which had the ROMs on. You can see that's it there. Plugs in, it's got the EEPROMs on it. Ran the other way, of course, but anyway, it's plugged in. Well, I've unplugged it, and I didn't really want that, so I left it out for the moment. So we've now got a board that seems to generate some sort of video. It's got a video RAM that seems to work, but we can't get it to read the ROM space properly. And we've got potentially 4 stuck bits on the data bus, and also some potential bad RAM. So I've got the circuit diagram up on the screen now, as you can see, behind my tester. And what I have done is I decided to sort of start looking at the diagram and look at the data bus in particular, because obviously there are stuck bits on there. So if I go back to the Z80, there it is there. The address bus all goes through some buffers, which is fine. I'm not going to bother too much with that. But the data bus, it's a bit slow, my thing. You can see it comes out the bottom and goes into this bus, which goes to a variety of different things. Like there's a buffer chip there which feeds the I/O in to the data bus. There are some other ones. These ones don't get fitted if this one's fitted, I've noticed. So we haven't got those, we've only got that, which is an LS245. And then we go on to the EEPROMs, which are over there, and they go on to the data bus, as you can see. And if we follow it through, we also have the RAM. We have some RAM chips, which are 2114s, so 4 data bits go into one, and the other 4 go into this. So the one that obviously will be affected is 7N, which is using D4 to D7, and they seem to be the ones on the data bus. There are some other buffers and things, but it's something which is generating an output when it shouldn't, I think, and it's getting the data bus stuck. Now what I have done is I've gone and checked that the buffer chips are not getting selected at the wrong time, i.e. they're actually disabled when we're reading the ROM. And the way I did that was I checked some of these signals here. This is the enable pin for the buffer chips over where I showed you that reads the I/O in, and I probed with the tester pins 4, 5 and 6 to make sure that was alright, and which it was. I probed the outputs of these, and I was getting results which were sensible, and everything basically seemed to tie up. So it was really showing me that as far as the circuit's concerned, it's enabling and disabling chips correctly, but I was still getting stuck bits. Now the interesting thing is, when I actually go on to the tester again and I set the address to 5000, which was where the video RAM was, okay, and I do a stuck check on that. Remember, the stuck check checks for stuck data pins, so we'll do 0800, which is 2K of video RAM. It's now, there's a reason for that one stuck, but basically they were all showing up as okay. Now remember, it did pass the video RAM to start with, which would suggest to me that obviously when it was reading the video RAM, the data bus was absolutely fine, because if any of those pins were stuck, then the video RAM check would have failed. So what I've done in the meantime is I've done very quick checks, and to try and isolate where the data was getting stuck, and I did check it on the ROMs. So for example, If I go to say address, go back to this again, sorry, we set it back to address 0. We're back to address 0. Now what I need to do is force high, which if you remember from previous videos of other boards, what that does is it forces the data bus to an input, which puts the mem request line low and the read lines low and holds them low, and the data bus is set to an input. So we can look at the data bus and see what's on it. Now on these ROM chips the data is actually on, I think, 14, 15, etc. So if I go to pin say 14 there, you can see it's actually coming up high on the tester, which does say that the data bus is actually stuck high. So the tester is telling me it's stuck high, and I'm actually measuring it as stuck high. Now what I did, obviously, once you get a situation like that, you have to then trace around all the different things that are connected to the data bus, make sure they're not getting selected, which is what I did. I used the probe for that, and I actually did some very simple things, like for example on, that's one of the buffer chips over there, I actually snipped the leg of the chip on one of the data pins to see if it changed the state of the data, and it didn't actually do that. But what I did do is, when obviously it was telling me originally the RAM was failing at address 4000, I think, which happens to be these two RAM chips here, 2114s. The chip I was interested in was 7N, because 7N handles D4 to D7 only. And what I did with that chip was, if you can actually see it, I actually snipped the leg of one of the data pins, which is pin 11, which if I go to the schematic you'll see, if I can get, I'll move the tester out of the way, pin 11, where is it? Go down, it's way down the bottom obviously, once this thing moves. So we're on pin 11, which would actually be, that's D3, but on that chip is actually D7. So what I did was I snipped the leg of that RAM chip on D7. So I've disconnected the RAM temporarily from that data pin. Now if I go and probe again, I'll move that out of the way, and I go and probe the data bus, we can do it on the ROM chips. So we're looking for D7, which is pin 17, okay, and we can check D6, which is pin 16, so 16 and 17. We're looking, both of them all stuck high, so those last four stuck high, remember, at the moment. So we'll look at pin 16 and pin 17 of the ROM socket and see what happens. So let's get this right. That's 13, 14, 15, 16, so on pin 16. As you can see, it's stuck high, as you'd expect. You know, I can check it on another data pin, say there. That's on, say, D3, I think, I remember right. That's yeah, that's pin 11, which is D2, right? So I'm on D2 at the moment, and you can see the tester is actually showing it as tri-state. It's not showing low or high, so it's actually showing it as a tri-state signal, which is what you'd expect. Excuse me. So I go back to 16, which is 13, 14, 15, 16, it's stuck high. Now let's look at D7. D7 is pin 17, and remember I have snipped the pin of that RAM chip. It's now tri-state. So by taking that pin of that RAM off the data bus on that one pin, it appears to have actually got rid of the stuck bit. Now this could tally up, because the tester was telling me that RAM, it detected some RAM, but it was faulty RAM, possibly bad or write only. Well, if I take the pin off, the data bus seems to be okay again for address 0. And we can go back to the RAM chip, which is down here, and we can probe. Where is it? I'll probe that pin there, which is that is actually the pin on the board which is going to the data bus. Not the RAM chip, this is actually it, and it's still showing me as tri-state. If I actually probe it on the chip itself, which is disconnected, remember, it's high. Now a RAM chip should be tri-state when it's not selected. So I'm going to check the select lines of that RAM chip now, which is There it is there. It's pin 8 for the select and pin 10 is write enable. Now remember, I'm reading ROM, so I would expect these to be, I would expect the select line to be high and the write enable to be high because I'm not doing anything with those, so let's check those. So pin 8 is there. Pin 8 is high, which is what you'd expect when you're reading ROM. And pin 10 is the next one along on the other side, and that's high as well. So the signals going into this RAM chip are correct, and really that RAM chip should not be having any effect on the data bus when it's not selected. However, it seems to be the outputs are high and it's obviously pulling the data bus high. So I think I'm going to stop this video and I'm going to change this RAM chip and we'll see what happens then. Okay.